Thank you very much for joining us today for maximizing value from your data with Lakehouse AI. Hopefully that's what you're all doing here, is coming for that talk. If you're not, I hope you enjoy that talk, because that's what you're going to get here. So quickly, before we get started, I need to do the legalese, which is tell you that, hey, everything we say in here is for informational purposes only. You're not allowed to get really upset if some of it doesn't come true. Having said that, just to level set with you today, that almost everything we're going to talk about today is in private preview right now. Some of it will go to public preview in the next couple of weeks. Some of it's in private preview. Some of it will be a little further out, but a lot of it delivers over the next 4 to 6 weeks kind of thing, right? We've been building this for quite a while. So, as you're watching this, as you're thinking about this, think about it that way. Also, if you are here and you would like to get into those private previews, we will have information to your account teams that you can reach out to them to get into those private previews nice and easily. So my name is Craig Wiley. I run machine learning and AI here at Databricks. I run product management for machine learning and AI here at Databricks. Been at Databricks for about a year. And previous to that, I was at Google, where I built Vertex AI and managed most of the Google AI stack. And then before Google, I was at AWS, where I founded SageMaker. And so been kind of bouncing around building these AI platforms. As my wife says, maybe this one you'll like enough that you won't have to feel like you need to go do another one somewhere else afterwards. I'm really very lucky today to be joined by Jan Newman from Comcast, who will be telling us about how Comcast is using Lakehouse AI to accelerate their intelligent computing outcomes. So, maybe slightly unpopular statement, given that I built some of these capabilities, but I would argue that the current AI platforms that are out there are broken. And the reason they're broken is because they're siloed and they're separate. They're AI platforms. And these are standalone platforms that have a series of interconnected services inside them, but they're really, hey, this is the AI platform. It's separate from your data layer, your production layer, et cetera. Not only that, but also the way you get data into these platforms is usually you export the data out of your system of record to blob store, right? So you go to your database, or you go to kind of your data lake, you find your data, you process it, you get it into the right position so that it's ready to train a model. You save that to S3 or to blob store of some kind, and then you import that data set as your training data set, right? That's how these models these platforms operate. Now, the problem with these, right, is that, first of all, it's a standalone set of interconnected services, but it's a standalone set of interconnected services that needs to be connected to your data layer, to your production layer, right, to your governance and tooling and your data catalog, right? It needs to be connected to all these systems. And often the people who are good at connecting those systems aren't necessarily the data scientists who are using the platform. Right? And so this starts to show us where some of this break is. Not only that, but this idea of I'm going to go to my data layer, and I'm going to export from my data systems a data set to train a model. Right? As soon as I've done that, that AI platform is receiving that data set naively. It has no idea what that data is. Right? It can't take any intelligent action based on that data, because it's just some random flat file sitting in blob store, right? So let's talk a little bit about what that means, and what is Lakehouse AI. Lakehouse AI is why I'm at Databricks. Lakehouse AI is something that really is unique to Databricks' ability to build, and what it is it's building an AI platform directly into the data layer. Right? Having a data platform or an AI platform that is fully integrated with the data. And so what does that look like? What that means is that we go take the kind of classic AI platform capabilities, and we repurpose them and refactor them back into the data layer, right? We don't invent new capabilities where you don't need new capabilities. Where there's already analytic tooling, we leverage that. Right? We don't just charge more for an AI version of it off to the side kind of thing. Right? So it's this idea of actually integrating these two platforms. Now, central to this, and I think you heard Ali say, maybe the most important thing at Databricks is the Unity catalog. Now, to me, the Unity catalog is super interesting because it's an observational catalog. And what I mean by an observational catalog is you don't have to do stuff in order for Unity to pick up what you're doing. What I mean by that is when I go build a table, I don't have to go register my table and then register the transform that builds the next table, which I also have to register. It does it all for me automatically. It keeps track of all of my actions and builds out a lineage graph from there, right? That is what creates, when you combine that with an AI platform, you start being able to do things that you can never do if you have a naive connection to the data. So let's walk through this workflow from left to right and kind of talk through what does it mean to be Lakehouse AI? What does it mean to have your AI platform built directly into the Lakehouse? So let's start with data collection and preparation, right? The first step we all take. Now, a lot of folks would say, hey, best practices for machine learning as it relates to preparing data and getting data ready is use a feature store, right? We've all probably heard, many of us have probably bought, I have built here at Databricks, we GA'd our feature store a year and a half ago, right? And feature stores are specialized systems, right, designed to organize, curate the data for machine learning folks to use, right? And then to serve that data to high-performance training and high-performance inference systems. That's all it is, right? It's a data catalog where you can curate your data and then serve it to high-performance training and inference systems, right? Oh, and then also, oftentimes, not only will it allow you to serve the data, also maybe you could do real-time calculations of the data, right? Calculate your features on the fly or real-time feature calculations. The problem with this is that it creates duplicate, unsynced copies of the data, right? Now I have data in my feature store, and I have data in my data warehouse, and I probably have data in raw data files in my data lake as well. All three of these are now at risk for falling out of alignment with each other, right? Not only that, but as soon as I take that data out of my primary data system and put it into that feature store, I risk breaking lineage. I risk breaking governance. Right? Now, all of a sudden, can I really be confident that the people who are using this data are the right people and that they have access to the right data, right? And then again, it's just another system that you have to learn, right? We know that having dozens of tools to do a relatively straightforward workflow doesn't always help. It sometimes feels good. It makes us feel like experts. But it doesn't always help with productivity. So what does that mean we're doing? That means we are putting the feature store into the Unity catalog. So we spent the last year ripping the back end of our feature store out. And now the Unity catalog is our feature store, right? You can discover data there. You can curate data there, right? And we've made it so that you can serve that data to high-performance training and inference systems, right? That was kind of what this feature store has to be able to do. So we've made it so that any table in the Unity catalog that has a primary key can be used as a feature table, right? Now, when you do that, not only do you now have one copy of the data, not only you now have your data scientists operating under your governance structure. Right? You have data lineage. Let's say I'm building a model, and I go and I say, hey, I'm going to use this table here, right? And the first thing I ask myself is, am I going to put this model into production? And if the answer to that is yes, I need to be careful, right? Because I need to not use the data warehouse values. I need to make sure I use the values that actually look like they do in production. In the Unity catalog, that's unbelievably easy. I'm at that table. I want to see what the values look like in production. Great. Open up the lineage view. Click on the furthest upstream table. Take a look and see what the values look like. Do they look the same? Do I need to run some sort of, now, if I'm going to move this model into production, I should use that table to train the model, right? I was talking to a customer yesterday, and I said, this one piece alone, this idea that, hey, when I move the model into production, the data scientist isn't handing off a data warehouse artifact, a model trained on the data warehouse, that then the ML engineer has to open up and say, wait, I can't use these values and these data sources in production. I got to go find the actual production data sources, right? The ML engineer goes and finds them, retrains the model. Turns out the model operates differently when it's trained on data that's structured differently, right? And all of a sudden, we end up with a very different model potentially in production than the ones that our scientists had originally designed, right? This ends that, right? It just goes away. No more training serving skew, right? And then our models can very easily just inherit the governance of the data they're trained on, right? Because that's an unbroken governance and lineage line at this point. So not only is the UC now our feature store, but it can now do real-time feature serving. This is ultra-low latency, real-time feature serving capabilities for the tables in Unity being used for features, right, that you're using for your machine learning capabilities. The only thing you need is a primary key on that table, right? If you have a primary key, we can use that as a feature table, and we can kind of host or serve any of your features in super low latency directly from that table. And we're not just stopping at feature serving. We also will support function serving. If you need to calculate a feature in real time, right? Hey, I care about not where this person lives, but their distance from our nearest brick and mortar location. Or I care not about their date of birth, but of their age, right? That's now can all be easily calculated in line during your inference call as a part of this, right? So that gives you a sense. We had talked about vector DBs earlier. So as part of this whole data collection and preparation piece, we have brought the feature store and feature serving directly into the Unity catalog. We also have vector DBs to support your large language model interests and use cases. But you can already see how this changes the AI platform, right? Now, all of a sudden, the AI platform is a cooperative part of our data stack, not a separate part of our data stack. Now, when it comes to model training, right, we're now going to go build our model. When we build our model, we can use a whole series of classical algorithms, right? We can use deep learning models. We can use LLMs. We can use various open source transformers or foundational models, as well as chains and agents and what have you, all available to you in our model training environment. Right? So, again, you have not only the ability to kind of access your data in the best way, but you also have access to all different shapes and sizes and types of models. Now, models are born from the data, right? They come directly. They are a descendant of the data. And, they need to be a bit more respectful about that. And what we mean is this idea of we can't have models say, hey, I'm an AI model, therefore I don't need to be governed, right? I talk to customers, and often I say to them, hey, how do you handle your model maintenance, or how do you handle your governance of your models? Where is your model registry? The most common answer I get is we have an Excel sheet with all of our models in it, right? I get it, but that can't be the answer in 2023. Right? We have large language models that are approaching AGI, and we're using Excel to store models. No, our models should be part of this data landscape just the way they are, just the way they ought to be, the way they are naturally, right? Descendant from that data, right? These models can inherit the governance, and it's an unbroken lineage chain with them. Now, models are also going into the Unity catalog. This means that the same tooling you use to manage governance can now be used to manage those models, okay? Now, something kind of neat happens when we put models in there, is that I told you before that we could support real-time functions as a part of the feature store. So given that models are in the UC, and the UC or Unity catalog is our feature store, now all of your models are also features to any future models you build, right? As easy as that, right? And not only that, but those models can also be used in SQL as UDFs so that your analyst community, those folks who may not have the capabilities that your data scientists have, your analyst community can run those models in SQL queries, kind of doing batch transforms or understanding, how to score it. I will tell you, this alone, working with customers in the past on, hey, you've got a model that your analyst community wants to use? Great. Let's put it behind an endpoint. Let's create an API wrapper such that people can call the API, right? It was this disaster of conflict around how we could make it really, really easy for the non-technical, the analyst community to utilize this. And now it's as easy as just adding an extra function into your SQL query. So you can see, right, already from getting the data, we benefit from being inside the lakehouse, from being inside the data layer. As we're building the model, we're again benefiting, right? As we're storing that model and using it later as a feature or in a SQL query, we're again benefiting from this idea of converging the AI platform and the data layer. So let's talk about MLOps a little bit. MLflow is the leading MLOps framework out there. I think it's at somewhere between 10 and 15 million downloads a month right now. It's bouncing around. I think Ali said 120 million downloads a year, that one sounds good. I will say within MLflow, we are investing heavily right now on large language model capabilities. A lot of those got talked about earlier today by Patrick and by Casey in the demo. Things like API or the model gateway so that you can control which model you're using and swap them out underneath, and monitoring for your models and comparison of prompt results across models, and experimentation comparison where the experiment itself may be a whole chain, right? We've also, I'll tell you, the one that was cleverest to me, the one that when the team did it, I sat there and went, well, thank you guys, that was just the smartest thing, was they just made it so that you could wrap SaaS APIs in MLflow. So now you can wrap OpenAI or Anthropic or Cohere or something like that in MLflow, and just sitting there in your model registry is OpenAI GPT-3.5, right? It can be used as in SQL. It can be used as a function in your models, right? Because it's a model along with all the other models in your registry, right? Now, this is not part of MLflow, but is part of the MLOps capabilities. We are investing heavily in the Databricks CLI for MLOps, right? Making it easier to set up infrastructure as code, as well as setting up deeper integrations with CI/CD pipelines so that you can actually have a deployable experience, not just a, hey, your model is available here, feel free to go do with it what you want, but so that you can actually have a robust CI/CD-backed versioned deployment system within your MLOps framework. And again, hopefully you're doing all this without having to refactor the whole model and find brand new data sources. Hopefully that all of the effort of that ML engineering team can be put to much more value, much higher value added capabilities. So we've talked about how data, we've talked about how models, and we've talked about how MLOps benefit being inside the data layer. Let's talk for a minute about model serving and feature serving. So we offer a model serving product. We went to GA with it this last March, I believe. Low latency, quick to auto scale, scales down to 0 when you're not using it, so there's really no reason not to use it. Both CPU and GPU availability for whether or not you're running kind of more classical models or larger deep learning LLMs or what have you. So this model and this model serving capability pairs nicely with the fact that we have feature serving, right? I talked about a second ago the fact that, hey, you've used our feature catalog, or you've used our feature capabilities in UC or in the Unity catalog. You now want to go serve that model. This is the best part of the Databricks AI platform in my mind, just so you all know. And it's actually a pretty underused part of the platform. But when you use us for inference, if you use us for inference, and you use us to manage your features, then there's no data pipelines. Right? You send us an inference. Let's say you've created a customer churn model, right? And it's customer ID and a bunch of information about the customer, right? You send us the customer ID, we go look up all the data. We bring it, we hydrate your API request with the data, and we pump it into the model inference. You don't have to do any of that, right? If you have multiple models behind that, we'll go orchestrate that DAG for you. We'll take care of it. We'll grab all the data that needs to go in those dependent models and put them in, score them, take the score, add the data that's needed for your model to that scored one and score your model, right? All of that's just done automatically for you, right? It is the organizations that have taken this on have told us that it is one of the greatest time savings. It's funny, I remember when MLOps first started to come about, and we started talking to people about pipelines and building more robust and repeatable deployment processes. I remember saying to a customer at one point, like, listen, this is like an order of magnitude speed up. Take advantage of it. We're still so nascent in the time of machine learning that I don't know when I'm going to have another one of those. It's no guarantee that every year I'm going to have an order of magnitude speed up, right? But we got one with MLOps. This idea of putting your AI platform in your data layer gets you another one, right? This is another order of magnitude like acceleration or productivity improvement relative to having to deal with multiple disparate systems that don't talk nicely to each other. So we've talked about how each of these capabilities makes it easier, makes it faster, makes it less error-prone, as you move into this. Now, as a part of this, I also want to talk about Lakehouse monitoring for a moment. We talked about Lakehouse monitoring briefly this morning, but Lakehouse monitoring is a funny product. Last year at Data and AI Summit, and I'm probably not supposed to say this part, but last year at Data and AI Summit, we announced model monitoring. And we were really excited. Hey, we're going to have model monitoring. It's going to be awesome. You guys are going to love it. We got to private preview. I think we were just about to go to public preview last fall. And we realized we had built the wrong product. We had violated our own design principles. And the reason we had done that is when you monitor a model, you don't actually monitor the model. What you do is you publish all of the inferences of the model to a table, and you just run window functions over the table. We were doing that. But that's table monitoring. That's data quality monitoring. And so here we were. We had built a data quality monitoring product for Databricks while we were building a model monitoring product without realizing it. And so then we stopped. We didn't want to introduce to our customers, hey, we now have these two products, a data quality monitoring one and a model monitoring one, and they do the same thing, but the model one costs more because it's AI. And we didn't want to go down that road. So we just said, hey, we're going to stop. We're going to stop our private preview. We're going to call a loss on that product and that work, and we're going to switch over, and we're going to build a Lakehouse monitoring capability that will monitor the entire Lakehouse. And with that, it will monitor your models. Now, when it monitors your models, this experience changes when you have an AI platform that's built into the data layer. Because now, all of a sudden, I'm not sitting there and kind of monitoring the model and saying, oh, guess what? Your model's drifting. I'm monitoring the model. But as soon as that model starts drifting, I'm looking at your features. Because I know where your features are. I'm the one who put them into the model for you, right? I'm looking at your features. And I recognize that, hey, feature number 4, the job that populates the table last night didn't run. There's a ton of nulls in that table, right? Now, today, I'll just tell you that. In the future, we can discuss whether or not I just go rerun that job for you. But today, I'll tell you, hey, feature 4 doesn't look like what you expect it to look like. What are we going to do? And by the way, it's not just that feature 4 doesn't look like we expect it to look like, and this model isn't working the way we expect it to. We know every other model that feature 4 is in, right? We know every other table that's a descendant of the table that feature 4 is in. We know that one of your executives just looked at a dashboard that includes data that feature 4 is in. right? This forward and backward lineage allows us to do things, allows us to give you information, give you the ability to debug not just the model, but to debug the impact of the error that created the model across your data stack. Right? These are the kinds of capabilities that you ought to expect from your AI platform, and they're completely unique because nobody is building their AI platform into the data layer. With that, I'm going to pause, and I would like to invite Jan up on stage to talk a little bit about how Comcast is leveraging Lakehouse AI.
Thank you so much, Craig. All these Lakehouse announcements are so excited. Who's excited here about them here in this room? Oh, yeah. Let's give a round of applause. My name is Jan Neumann, and I lead the AI and Tech COE at Comcast. And today I want to talk about how we at Comcast use Lakehouse AI components. So Comcast uses AI in many different of our verticals, starting with entertainment, like in the Xfinity Voice Remote that we already talked about here at the Data and AI Summit in 2019, our personalized recommendation systems. Recently, we won an Emmy for a video AI product where we analyze all our broadcast content to create new interactive experiences and contextual advertising. We're building smart cameras for the home, conversational, smart intelligence assistants for agents, customers, as well as our technicians. We're optimizing the network using AI, as well as kind of our marketing and sales kind of campaigns. And we keep our customers on our network secure from kind of attackers using AI. All of this depends on a data and AI platform. Like traditionally, we kind of built a lot of these solutions in isolation. But we quickly learned that leads to a lot of duplication, and as we kind of learned here, it makes it just very difficult to develop and deploy AI solutions in a safe, responsible, and secure manner. Another thing which is very important is the integration of all these solutions with our standards and policies, as well as our educational and talent experiences. So how do we think about the platforms? What are the challenges that we need to solve? So one thing that you saw, even like in Craig's slides, I think he actually makes the kind of machine learning process look way too easy. Like you take a problem definition, you just collect some data, you define some features, you train a model, you deploy it, and voila, you have an AI and ML application. Unfortunately, the reality looks more like this. It's many different steps, upstream, like some of the upstream decisions that you're taking have downstream effects, and it makes it very hard to kind of optimize the experience if you don't get those choices right. So how do we think about the platform? Like our design principles were really to think of the platform as a paved road to success that balances the freedom to innovate for our teams to choose the right tools for their job with the guardrails that our standards and policies and also kind of the expectations for minimizing duplications bring into the platform. So what are the abstractions that we're working with? One of them already, Craig motivated the use of a feature store. It allows us to both link the data collection and data preparation together, but it also separates out the model training and inference from the data platform so that the way you train and do inference can be separate and doesn't need to know about all the details kind of that are in the data platform. Similarly, we want to separate out the training and inference portions so that our team can use the latest training frameworks because, as you know, I mean, especially with generative AI right now, every day a new framework comes out, and we want our teams to be able to use them. At the same time, the main cost of a platform is really incurred during inference time, so we want our ML engineering teams to be able to optimize these experiences. And then furthermore, all of this needs to be tied together with like a common governance and metadata layer. I mean, kind of as you see, this kind of maps very well to the Lakehouse components. Specifically, what we are using is Delta Lake for our data platform. We're using the feature store. We're using notebooks and workflows for our model prep and model development environments, MLflow for the model registry, and then Unity Catalog to tie it all together. At the same time, we're still using a lot of allowing our teams to bring their own models for training and inference. Though I have to admit, like with all the announcements in the keynote today, which I couldn't build into the slides yet, there's probably many more of these bring your own kind of components will also be filled with Databricks soon. So what are some of the use cases that we're currently running on this platform? Like on one extreme, like the batch use case, we're doing churn prediction. Our enterprise business intelligence team is using it to optimize sales and marketing campaigns, and they chose XGBoost for their underlying model, and they're using Spark to score it once a day. On the other hand, kind of the team under me that builds the Xfinity Assistant, and where we want to recommend the next best action to our customers of what they should take, troubleshoot, look at their bill, et cetera, in the Xfinity app, they use the PyTorch recommendation model, and then we run it with Redis as a feature cache and NVIDIA Triton to solve the models. Another challenge that we want to solve with our platform is to democratize the access to AI, like another theme that you heard about in the keynote today. So currently, if you're a domain expert, I can probably trust you that you are able to handle the data preparation stage. You're the expert, so you understand the data that you're working with, right? And you can probably inject your knowledge in the form of features. At the same time, you still need help from other people to kind of make it all work. You need probably help from a data engineer to kind of ingest the data and set up the pipelines. You need help from a machine learning expert to kind of help you choose the right training frameworks, and often for more complex models, even get it to converge and kind of create a model. And then help from an ML engineer at the very end to kind of deploy the model and optimize the kind of performance. So where we have been going is to kind of really get to this vision of AI everywhere is to codify best practices via automation and templates. So specifically, kind of changing the data engineer and encode that into self-service ingest and pipelining solutions, offering low and no-code interfaces to lower the barrier of entry to our kind of domain experts even further, encode the expertise of the machine learning researchers into AutoML solutions as well as use case templates, and finally moving more and more towards like serverless feature deployment, as well as integrating the machine learning deployment workflow closely into our CI/CD platforms. Another challenge is extending the platform for generative AI, right? Any talk at the Data and AI Summit has to mention LLMs and generative AI somewhere. So this is like something that recently came where we're extending our traditional machine learning platform now to generative AI. On one hand, we're looking at adding a semantic data layer, both on the metadata, kind of similar to Lakehouse IQ, right, operates on Unity Catalog, so we're excited about kind of what is possible there once we get a chance to try it. But also doing semantic indexing of all the documents and the unstructured data that is within our kind of data lake, so that it becomes accessible for applications. But also, again, we can use natural language to query it and use it in applications. The other areas that we want to enable like access to these foundation models to our teams, both open source, kind of optimized models, as well as kind of commercial external models via APIs. We also offer kind of the capability to do the fine-tuning of these LLMs within the platform, as well as providing even relatively full-formed example use cases, such as a retriever-reader framework that our other teams can use to build intelligence AI systems into all the internal and external tooling that we have. And even we want to use this framework to build an AI assistant to help with the kind of development of AI solution within our platform so that the domain expert, and I try to capture this in these colors, is truly able to go all the way from the beginning, from the data preparation state, all the way to the deployment stage. So I hope this was interesting to see how Lakehouse AI is paving the way to AI everywhere at Comcast. And the platform, kind of with the help of Databricks and Lakehouse AI components, is truly making the AI process as easy as we usually show it on the slides. So, and with that, I'll give it back to Craig to wrap it up. Thank you so much.
Thanks, Jan. So let's wrap it up real quickly with, we talked about a lot again, about the benefits of this idea of an AI platform built directly into the data layer. We get benefits not just on, it would be very obvious if I said, hey, what if you built your AI platform into the data layer? What if the data layer just was your feature store? Like, that would be really easy, and if that were the only thing we got here, I don't think it would be much of a story. But what we find is that every single step of the journey, every single step of the workflow benefits from being tied back to the data layer. At each step, you can make better decisions. We can make more intelligent, thoughtful decisions. Right? We're not at a point where we're recommending features to you, but if you have a primary key and an objective column, we know all the queries you've written that have included those two columns, right? So the idea that this could be a much more intelligent platform built off of your capabilities is what gets us so excited about this, right? Features in UC, models in UC, unified governance and lineage across all of it, real-time feature and function serving, auto magic feature serving, the Databricks CLI, and then obviously LLMs everywhere, right? I think every single piece of this platform and every single team that I work with has taken on efforts to make their capabilities more robust and more ready for all of the LLM usage that we're getting. As Patrick said, we're seeing a 25% month-on-month growth in the use of accelerators right now, right? So this is not just something that people are kind of excited about. This is a massive, massive transformation to this industry in this space. Before we wrap up, I did want to talk about a couple of other sessions that it would be a mistake to miss. So tomorrow at 11:30, Nick, who's right here in the fourth row, will be doing more or less this same talk, but he'll actually be showing it to you. He'll do a demo of Lakehouse AI from end to end. He'll show you how all of this works. I would highly recommend going to the talk. It's going to be a ton of fun. Later this afternoon, you do have an LLM ops talk, as well as a how to build an LLM on a budget, and then also the Lakehouse monitoring, learn how to reliably monitor your Lakehouse talk today. So highly recommend attending these talks. I think you'll find a lot of value in them. Tell us what you think. Tell us what we should go do next. Get trained. We have a couple of minutes left if we have a question or two. Yeah, there's the mics, but yeah, shout it out.
How do you deal with the overload of data? So essentially, you have AI embedded in your lakehouse, right? Every time the AI is called, every time training happens, every time the question is asked, that creates more data that the AI ingests again.
Yeah.
So it's recursive.
Yep.
So how do you?
Yeah, so the question is, how do you handle all of this data, right? You've got all the data you trained the model with, and then the model, as it's working, is generating more data, right? We're writing that table of inferences. You're probably joining your ground truth to that table. You're probably joining your business outcomes to that table, right, and monitoring those as well. How do you handle all of that? This is the proverbial challenge of this time is that, yeah, it is a tremendous amount of data to handle. Having the right retention policies, having the right governance controls, again, makes it so that these models, they're not writing their logs to just some random log store that you have to go to. They're writing it right back into your data lake where you can use the Unity Catalog capabilities to build policies around retention and what have you. One last question, anyone else? Otherwise, we'll be, oh yeah, we got one in the back. Yeah, go for it.
Hello. This might be for Jan. I'm just wondering what might be the specific use cases for extending the platform to include generative AI specifically.
Yeah, here's the thing about generative AI that I've seen, is that the workflow is the same. Right? The only difference is that when we talk about pre-processing structured data, we talk about taking the log form of all the values or something like that. Now instead what we're doing is we're talking about tokenizing and chunking and embedding the data, right? So there's a few different verbs, and there's a couple different nouns, right? We now have a vector DB, and we have embeddings and things like this. But it's the same workflow, right? We've had transformers running. Right? These large language models are all transformer architecture models. We've had transformers running on this platform for 4 or 5 years, right? Ever since transformers were first around, folks have been running them on the platform. Now the difference is that we're dealing with a lot of language-based data, and we're dealing it with at a much larger scale than we've dealt with it before. But otherwise, oh, and we don't have a great objective function to tell us when these models perform well. But other than that, it's more or less the same workflow, right? And so a lot of what I talked about today was in the framing of machine learning or more traditional machine learning. But it's the same, hey, having your LLM be fully governed, having your LLM inherit the governance and have a full lineage train across your data space. Those are all the same equally important ideas, right? As the EU gets ready to bring the EU AI Act on all of our shoulders later this year, these ideas of governance and lineage aren't going to be a choice for very much longer. So with that, I'm going to wrap it up. Jan and I will be up here in front to answer any questions you might have, but would love to chat with you if there's anything we can help with. Thanks, all.
Thank you.